Hi, everybody. Okay. So in this session, I will try to explain how Amazon Elasticache works, what it is, why we are using, how we are using it in our production workloads. Uh, if you are using Redis open source in your project already, you can think about it is the wrapper in AWS. Of course, this Elasticache does not only support Redis, it also provides service for Memcache, also Volky cache. So we will take a look at Volky in this session. If you didn't know the history, a couple of years ago, Redis just changed its licensing model where if you are using Redis, if you are distributing Redis in your production workloads, you need to read their licenses carefully because they can, so they have rights on your products if you are using Redis after some version. Then there was a parallel project which is called Volky, and it became more popular after this license change. And AWS decided to include Volky caches inside the Elasticsearch service. In this session, I will try to explain how it works, what is Elasticache, and also we will be deploying a Go application in a normal EC2 instance, and we will connect from our application to Elasticache Volky cache and to see how it works in general. Okay, I think, okay, yeah. Amazon Elasticache. Our main motivation is, you know, the very popular problem, right? You have an application and every request is hitting database, which is hurting your database. Especially if if you have a data which does not change very frequently, but all the time you are hitting your database. For example, you have category page and category information is not changing very frequently, but whenever somebody opens your main page that contains categories of your products, it always goes to the database. But you could cache this page, right? Because it is not changing so much. This is our problem. We will take a look at that one. Yeah, caching 101, maybe this is not the hardest problem, but there is another problem, which is cache invalidation. I can say that it is the hardest problem in software engineering. We will use cache aside pattern and we will take a look at TTL and we can take a look at how invalidation works. And in AWS Elasticache, we will see what are the engines, what are the deployment options, and some kind of concepts. In today's demo, we will take a look at our architecture. And of course, hands-on demo, as always, we are doing in our sessions. Our problem is, as we mentioned earlier, your customers tries to access one of your web application. It contains page rendering, of course, because it took data from the backend API and render inside the web application. But on every request, you basically go to database. You are hitting database. We need to somehow eliminate this problem. Yeah, Grok. Hi. But this is the same product page. You are basically doing the same query, maybe thousands of times per minute, but all the time you are going for database. Of course, you can ask, okay, what is the problem then? You can hit the database, so what? But if your request count increases, you will see there will be more connection to your database and there will be a bottleneck on the CPU. Why? Because of course you can use connection pooling, but does not matter. um, even you are using connection pooling mechanism, there will be some kind of latency because you are doing a connection from your application to the database. Um, but Redis also is on the remote, right? You are doing a connection, but there are some kind of difference between database and Redis-like technologies like Volky. In database, you basically deal with disks. Of course, there are some operations in memory, but you mostly deal with disk. And but in Redis, Volky, or Memcache, you can think that it works in memory. That is the main difference. Um, since you open a connection to database, there will be CPU bottleneck because there will be different port numbers for each connection. And the CPU inside the database instance, it should do context switching for this separate connections. That's why while you are spinning up a database, there is a port limit, right? Or connection limit. For example, you spin an RDS database in your system, and there is a connection limit there. There is a reason for that, to not harden your CPU. If you don't have any kind of cache side pattern, that means you are not using Volky. That means every request goes to the database, which means there will be a latency in your system. Maybe you can think that, okay, I can scale my database then, but you can think of database. You cannot scale database easily, right? And maybe you can do a vertical scaling. That means you can increase the spec of your machine, of your database instance, but it is not easy and it's expensive. For example, you cannot scale your database as you are scaling your normal web application or REST API. They mostly do not keep state. That means you can scale them horizontally. But when it comes to database, you cannot do it very easily, especially if you have a cluster or if they are if they keep state like master, replica, etc. You can still scale it, but it will not be fast. So scaling your database based on the request is not a feasible option in production environment. Of course, you can calculate your expected customer, and then you can design your entire database system by looking at that numbers, and you can periodically revisit that. But we are talking about a dynamic change on the request count per minute. So, caching 101. We will use cache aside pattern, which means whenever you make a request to web application, it will first ask this data to cache, and then if there is a hit, it will return data immediately from the cache. But it will miss the query if it cannot find anything inside cache. It will do a database query at that time, and after database returns, it will set the value inside cache. So this is very, very basic cache aside pattern you can think of. So we talk about very simple logic cache aside, yes, but what is Amazon Elasticache? Most probably you have heard about that. I don't know if there is anybody which already heard about Elasticache, but it's fully managed in-memory data store service on AWS. It supports three engines: Volky, Redis open source version, and Memcached. Memcached is very, very old technology, but it's widely used, believe me. Especially while I'm writing PHP applications, Memcached was the very popular cache layer, which we mostly use in our production applications. But Volky, Redis OSS, and Memcache, you have those three options. So again, what is Amazon Elasticache? We are still talking about Volky, Redis, Memcache. They are open source. You can find it, you can install it on your machine. Why Amazon Elasticache? Because AWS handles provisioning, which means it prepares your machine, right? And it deploys Volky, Redis, or Memcache based on your selection. And When it comes to, for example, security patching or periodic update, it can do the patching for you. That's the main idea of the technology wrappers like AWS, Amazon Elasticache. Monitoring, of course, based on your technology, you can see basic monitoring metrics just inside Elasticache dashboard. There is a failover option, which means you can deploy a multi-AZ availability zone. There is a multi-AZ option of the deployment. When you do that, there will be some kind of failover options. And finally, there is backups. For example, if you deploy Redis on your instance, and you manually control that, most probably you don't have backups, you don't have failovers, and maybe you don't have monitoring, and most probably you're not doing patching very frequently. You only provision and install the Redis and forget about that. Or you install Volkey and forget about that. But here, these SaaS providers exactly doing this operation for you. And Amazon Elasticache, you cannot access it from the public endpoint. It is deployed inside a private VPC. So your application can only connect to this AWS Elasticache instance. We are talking about microsecond reads here. You can do millions of operations per second, and it scales horizontally. Yes, scaling database is very hard, but when it comes to scaling Volkey or Redis, it's not so hard. You can do that. And Amazon Elasticache already do it for you. What are the use cases for caching operation? You can do page or session cache, right? You have a page. It is not changing very frequently. You can just cache it inside Redis or Volkey. And when somebody tries to open that page, it will return from the cache. Or you can store the customer session. Whenever you make a request to one of your web pages, you are checking if the user is already authenticated or not in order to show a restricted page. Instead of doing a request to backend side or database every time, you can check it inside a cache, which is stored inside Volkey or Redis or Memcache. You can maintain your leaderboards, right? You just build a game, your feature $1 million game, and deploy it to iOS App Store, and lots of customers are using your game. Then you can think that, okay, let's build a leaderboard that you print the score of your customers inside this leaderboard, and it's changing very frequently, and you just wanted to do some kind of pops up there. You can use Redis Volkey for this operation. You can do rate limiting, right? Think about rate limiting strategies. You can use different kind of bucket algorithms, right? And especially if you have only one instance, you can maintain the bucket usage inside in memory. That's no problem. There is no problem on that. But if you scale your application instances, for example, 3 replicas for your product REST API, then you need to maintain bucket limits inside the central cache. So you can use Elasticache for rate limiting. And as I said, you can use PubSub for this operation. You're welcome. So, what are they actually? Volkey, Redis, and Memcache. When you talk about Volkey, it is BSD3 license, Linux Foundation. Redis OSS has Redis. There is a change in their licenses after Redis 7.x. But after Redis changed their license, I started to use Volkey, by the way, because I didn't want to get another problem related to licenses. Redis is the very first open source project. It is, I think, the initial release done on 2007, maybe stable one released in 2009, but it is very old project, and it is always known as open source project. Once they changed their licensing strategy, everybody just started to use Volkey, and I am one of them. So we quickly changed all of our Redis instances with Volkey, and we are very happy with that. If you replace Redis with Volkey, you will see your existing Redis clients will continue to work. There is no difference. Memcache is BSD license. When it comes to data structures, Volkey supports strings, hashes, lists, sets, sorted sets, streams. Redis also supports same because Volkey is the fork version of Redis. Memcache only supports strings. As I said, it is very old technology, but very simple to use. Replication failover, it is supported inside Volkey. It's supported in Redis, but there is no such a thing in Memcached. When it comes to persistent backups, Redis and Volkey supports that, but Memcache does not support this persistent backup. When it comes to PubSub or Lua and transactions, Volkey and Redis support that, but Memcache does not support such a thing. When it comes to multi-threaded operations, Volkey fully supports it, but the Redis has partial support, and there is a basic support in Memcached. When it comes to price on Elasticache, Volkey is the lowest price, has the lowest price, and Redis and Memcache has standard support. So again, we already said that Volkey is the open source fork of Redis. Whenever Redis introduces a feature, Volkey also tries to support that. And it is backed by AWS, Google, and a bunch of other giant technology companies. And it is fully wire compatible. That means if you have existing Redis client, for example, Redis Go, and you were using Redis server, if you replace Redis server with Volkey, you will see your Redis client will continue to work. And this is very good. So what about deployment options? When you take a look at AWS, in most of the services, you will see there is serverless options and you can design your own cache. In serverless version, you don't deal with nodes. You don't know servers. You scale automatically. Since you don't have a node, your payment calculation is done gigabyte per hour stores, and you virtually deal with elastic CPUs. And there is only single endpoints. You can also use multi-AZ, TLS. TLS is always on in this setup. If you have spiky unknown workloads, this is the best option. So if you don't want to deal with this scaling operation, you can directly use this one. But there's also a design for your own cache. As I said, if you know your customer trend, if you know your traffic during the day, or maybe for 1 year plan, you can design your own cache. You can calculate how many nodes you need, etc. This kind of things. You basically choose node type, shards, and replicas, and that's it. You deploy the Elasticache, and you use it within your application all the time. In this setup, you pay per node hour. That means if, for example, if you are using cache T4G micro instance type, you need to check the pricing for this node, and you are charged hourly for each instance type. There is a predictable cost here because you reserve a node which has a fixed price, and if you use, for example, 10 hours, you can multiply it with unit price, and that's your cost. And you have full control over the params because during the deployment you can set additional params there. And be careful about one thing. When you deploy Elasticache, you will get Volkey or Redis or something. But keep in mind that AWS Elasticache does not provide full commands in your Redis CLI. You can directly use Redis CLI with Elasticache, but you will see certain commands will be disabled. For example, you will not do maybe shutdown or maintenance or something like that. A couple of commands are already disabled inside AWS because when it comes to maintenance, AWS handles that. You cannot do that. So when we talk about cache cluster, This is the logical unit you create first, and then you connect from your application, right? And when it comes to node, it is just EC2, size chunk of RAM. And this is the running the engine. Most of the services, for example, Kubernetes, Elasticsearch Kubernetes service, so Fargate or some other bunch of services, they are all using EC2 if they maintain a workload. For example, if you deploy a Elasticache cluster, you will see they are using EC2 instance on the backend side because the AWS needs to deploy AWS into some VM. They are basically EC2. And you can select which EC2 instance type you prefer. So shard is not only is in Elasticache or Volkey, it is used on other technologies, but here assume that one primary and read replicas holding a slice of the key space. If you have cluster mode disabled, you will have only one shard and all the data on one primary plus replicas. Very simple. So cluster mode disabled, that means your Redis instance, Redis deployment, your Redis platform or Volkey platform, it is not a cluster. That means you have only one shard and all your data is inside your primary. But if you have additional replicas, they will also have the copy data as you have in the primary. But if you have cluster mode enabled, that means you have a Redis cluster, that means you have many shards. Many shards means the keys spread by hash slot, and if you want to scale your writes, you can use this cluster mode. There is also multi-AZ, multi-availability zone setup, auto failover. For example, if there is a problem in the primary node, you will see one of the replicas will be automatically promoted to primary. The endpoints are primary, reader, and configuration. So configuration is enabled on the cluster mode. But if you want to do writes, it will use primary instances. If you want to do read, it will use the read instances, mostly replicas. So in our architecture, your customer makes a request. You can think that it is a curl request or browser request. It will go to EC2 instance, which we will deploy our application into. Go application runs on port 8080. It is inside public subnet, and in Elasticache, your application connects to Elasticache, which lives inside the private VPC. And it is using same port as Redis. Of course, we will use default VPC. I don't want to deep dive into VPC internal right now. There will be only one region, one AZ is enough for our demo. And we will have two security groups, one for application security group, which is inside EC2, and we will allow this EC2 instance to connect to caching security group. So you cannot connect to Elasticache directly from your computer. Only EC2 can connect, but you can connect to EC2 from your computer. Elasticache has no public endpoint, as we said, and the app must be inside the VPC. So it will use the private endpoint. We will have very simple application. As you can see, a demo app. We have a key here, which means this is the page, product page, and there is an ID, product ID. What we do is we try to get the cache by using this key. If there is a result, we just return it, right? Here, as you can see, we are setting X cache hit. That means you try to get a page, you get the response. If you see cache hit, that means you return it from the cache. And as you can see here, we are not reaching database, we just return HTML data. But if you cannot find it inside cache, it will do a slow query, basically. And after this DB operation, you set this value inside database. Of course, there is a TTL, and you return the value. This time it will be cache miss. This cache hit, cache miss headers, they are important, especially for your browsers or clients. So if you have a chance to do that, please set that headers to understand if it is coming from cache or from database. What about TTL and invalidation? TTL means the maximum staleness you accept. For example, set key value and it expires after 60 seconds. If you provide a short TTL, you will always see fresher data, but you will have more misses. For example, you put a product page into the cache and you set the expiration date as 60 seconds. Each minute, you will see the product page cache data will be removed. That means after 60 seconds, you will go to database. You will not return from the cache. But if you provide the long TTL, you will have fewer DB hits because the cache will live there for a long time. But this time, you will have stale data inside cache. You need to take this into consideration very carefully. Also, you can do explicit invalidation based on the events or some manual configuration. You can delete a specific key from the cache whenever a product data is updated. As you can see, there is a key naming here. This is a page, product page, and product ID is 42, or session with an ID, or user with an ID 7, and profile. So this is profile information of the user with an ID 7. That's the main idea. In eviction policy, when, for example, if the memory is full, you will see list recently used keys will be automatically evicted from the in-memory space. Of course, never trust on the cache. So do not do your design or think about source of truth, vault key, for example. Always use some durable store like database, for example, because you can always rebuild cache by using database from database. So I think we have enough theory here. We can now do a real demo, real application by using these theoretical informations. One sec. So first of all, let me show it to you again. Here I have a demo application. As you can see, we have only main.go, nothing else. We also have, of course, a makefile. I like to use makefile because I don't want to memorize what was the available commands, etc. But here, as you can see, it is doing a Go build based on some kind of architecture, and you can also run the application. But here, as you can see, we will need a cache address. Of course, I will not use this inside my local, but I need to build my executable binary first in order to deploy and run inside the EC2. But let's us check this demo again to see main.go. As you can see here, we have a bunch of environment variables, cache address, which means the AWS Elasticache endpoint. We will have cache TLS and cache TTL. TLS is for, if you set it true, that means your in-transit communication will be encrypted. So you know there is two kind of encryption. encryption in transit, encryption at rest. And encryption at rest means you send a plain text data to, for example, Volkey. Volkey stores your data into disk as an encrypted format, right? But if you use encryption at trusted, you will see you will also use encrypted messages. You will send encrypted messages to Volkey. Yeah. Cache ETL means this is default cache. This is the global cache setting for we will use page operations. But TTL means time to live. Assume that you put a value inside cache, and after how much seconds you want to remove this from cache. Port is used for application. 8080 is our application port. We have a struct for products. It contains ID, name, and description price, right? This is our, let's say that struct, Pojo, whatever you programming language you have. We have some sample data, 5 products, each have ID, name, desk, price. Also, we have some kind of variable for our application. For example, there is a singleton instance of Redis in our application. When you run your application, you will have an RDB instance. We have TTL, hits, and misses. So they are used for some statistics. This slope query, this is just an example. You see from the products ID, we do 800 millisecond latency, and we return an HTML format, and it contains some dynamic values. So instead of using real database, I just wanted to simulate it by using inline structs to make it very simple. We have an HTTP application, and it contains a product handler. You see there is response writer request. Whenever you make a request to products endpoint, of course there is an ID there. We construct our cache key by using page product and a variable ID. We also have a start variable as the date of now. If there is a no cache inside query, we try to get it from the cache. If there is a value there, we update the statistics. You see hits. We add 1 there, and also we set caching headers and return the data. Also, we logged it inside the application console standard output. Otherwise, if there is a problem getting the cache value, we print a message, and that's it. If there is no data in the cache, we simply get it from database, but it is not a real database. It contains a simulated latency inside query. If there is no data, we return not found. Otherwise, we misses add 1. So in this case, we basically cannot find anything from cache. But after that, we set it inside cache. And this is our response headers. We have index handler. In index handler, we print basic HTML values. That's it. If you want to see statistics, you can use stats handler because they are using hit, miss, and TTL, as you can see. There's a flush handler in order to remove or flush cache. There's a health handler, health endpoint, just pings the Elasticache instance if it is ready or not. Our main application, it tries to get cache address from the environment variable. If there is no such a value, your application will fail. You need to set it like this. And we try to initialize our caching client options, and we generate an RDB here, Redis new client. And you see this context value, 5 times second. Let's see where we are using it, context. Yes, you see, we try to connect to Redis Elasticache, and if it cannot get a pong in 5 seconds, it will do a timeout, and it will throw an error. But otherwise, we have all the handlers here. We are using port value from the runtime environment variable. If there is no value, we use default 8080. We are listening on port and listen on surf. That's it. So now we will just visit AWS console to spin up a couple of things. We can always build our application like this demo, make build. We already had a build operation. As you can see here, it is built. So in we are using Stockholm region. I hope we have some instance type available there. But before doing that, let's go to the security groups and create security groups. EC2 feature. Yeah. In security groups, we will create two security groups, one for app, one for cache. Here, create security group. This will be app security group, and we can use default. When it comes to inbound rules, we will allow 2020, 22, and 8080. So here, we'll add a rule, not custom TCP. This will be SSH. And here it will be my IP, so I can only connect. I will add another one, custom TCP. This time it will be 8080 because this is our application. I can also set this my IP, by the way. Create security group. This is for our application, and there will be, okay, allow app access. Okay, create security group, and I will create another one. I will create another one, which is cache security group. Allow Elasticache. Again, inside default VPC, this will be custom TCP and Redis port. Here, we will use another operation, but let's see. Okay, you see, to this port, only application can connect. You see, you can allow a security group to connect to another security group. So our security groups are ready. Now we are ready to proceed with the deployment maybe. Okay. Now we can create Elasticache. Elasticache. We will create Volkey caches here. When you say create cache, you will see the configuration. For example, engine is Volkey. This is recommended. Deployment options. In deployment options, we will use node-based cluster. We will design our system. And creation method will be cluster cache. We will not restore from backup. Set all configuration options for new cluster. So we will use that one. Cluster mode will be disabled to make it easy. And in cluster info, let's name it as demo cache. In the description, demo cache cluster. Okay. So location is AWS Cloud. We will not enable multi-AZ, of course. Auto failover. Let's be it like this. In cache settings, you see there is an engine version. It is up-to-date version. Port number is correct. Parameter groups, yes, we can set this one. And when it comes to node type, it will be cache T4G micro. Cache T4G micro, right? Our tiny cluster. Number of replicas, we will use 0. Okay, hyperderm, subnets. So it will create a new subnet group. Let's say that this will be demo subnets. This is optional, and this will be inside default VPC. Available zone, there will be no, but there should be a security. Where is security group? Ah, yep. Okay. Let's do the next. Security group will be here. Okay. Encryption at rest or transit. Encryption at rest, it is enabled. Default key. In transit, I will disable this one for now. Selected security groups. In selected security group, it will be cache. Here, it will be cache security group because we created it for Elastic. Backup. What do you think about backup? Okay, it can stay. So this backup enable automatic backups. For now, I will disable this one. For maintenance, there is no preference. This is for um, preparing your maintenance dashboard and auto upgrade from minor version. If there is a new minor version, it will be automatically upgraded by AWS itself. Logs, it can stay, tag, next. Okay, we set all the value and create. Our Elasticache cluster is on way, so we can launch an instance then. While it is creating an Elasticache instance, we will deploy our application. Let's see. So now time to create an instance. Launch an instance, launch. The name will be demo app. And we will use Amazon Linux. Okay, it can stay. What about instance type? Instance type will be T4G micro. T4G dot micro. Let's use it. Ah, okay. Will it be an ARM then? T 4G micro. Okay, now it should be okay. So when it comes to key pair, I will create a new key pair. What can I say here? Demo key. So you need to store this key very carefully because if you lose it, then you cannot access this EC2 instance. For the network, we will use default one. For the security group. Okay. For the security group, we should use application, right? This is the core disk value. There will be 8 gig of disk with GP3. This is the root volume. Then we are ready to launch our instance. That's cool. Now we can connect to our instance. Let's see it here. But we need to wait for it to be running. So it says it is running. Let's test it. So in downloads, You need to do change the mode of the file as 400 due to security reasons, by the way. What we will do is we will SSH copy our application to the instance. So what is our IP address? IP address is this one, and SCP. What is our key? Demo key, and you need to provide local executable binary. So here in our case, you come on. I design a demo page cache. So this is our binary. I need to copy this one to the EC2 instance. So here our IP, and we will copy it to user home folder. Let's do it, but no such file or directory. Okay, I can fix it. Page cache serve. Okay, so we need to copy this one. That was the problematic. Page cache dash Linux dash ARM 64. Okay, okay. We just copied our demo key pem ec2 user at our IP address. Yep, we are inside here. When I list it, I can see page cache Linux ARM64. So I think I can directly execute this application, but it will need a Redis endpoint, Volky endpoint. Let's run it, page cache. As you can see, cache address is required. We need to export it. Cache address is equal to this one. So what we will do is we will grab the EC2 Elasticache Volky instance endpoint. Here, Volky caches this one and prime. Oh, where is the endpoint? Oh, it is still creating. Okay. Why you are so slow? Okay, we need to wait for primary endpoint here, but it's still creating. We should wait for that. Let's wait. Hmm. So as you can see, the nodes are creating. Uh, Okay, this was the almost latest step because after this we need to connect our application and make a request. That's it. Come on. Of course, you can use the MCP integration in order to not deal with UI. It's up to you. Refresh. So it is triggered 9 minutes ago. Let me just, how much does it take to create AWS Elasticache? Okay. 8 to 10 minutes. So that means it should be up and running soon. No, we will wait. Still, on it's been already 10 minutes. So you should yeah, it's already been 10 minutes. Okay, it's available. Available. Okay, cool. Now let's connect to our instance. Demo cache. So there will be a primary endpoint. I will copy this one. And there's also reader endpoint, but let's use primary one. Here inside our instance, I will export this as a cache address, primary endpoint. Okay, I use this one and I will run this application. Okay, the application is listening on 8018. So that means I can connect to this, I can make requests to this endpoint. First of all, let me create another, let me create another one. And here, export IP is equal to my IP address. Then I will do series of commands. First of all, this one. I will make a request to product one. As you can see here, it says cache miss because we just made a request to this endpoint. Let me do another one. This time it is a hit. As you can see, it was 801 milliseconds, right? Which means it's almost 1 second. But think about this, 458 microseconds. It is something like, yeah, you can see the difference. So this render time is important. 800 milliseconds and here microseconds. Okay, what else? And you see the content length. Content length, same, because this one is coming from directly from the variable, but this one, it is coming from the cache. So when I make a request, oh, why? Okay. Why it is missing? Because it's already been 60 seconds and time to leave worked here. Okay, let me run a couple of, so it's nearly same as an experience. So we did what about this? Mm, Can we do stats, for example? Yeah, you see hit 7, misses 2, TTL 1 minute. You can flush the cache if you need cache flushed. And when I do another request like this, you will see it will miss. When I do another one, it will hit. So if I do the stats, you will see hits 8, misses 3. So this is our stat endpoint. And we just made a demo on this, but let's just open here and see the metrics. As you can see, CPU utilization, you can take a look at that one. We need to wait for a while in order to see these metrics. Okay. Try adjusting the dashboard time, 3 hours, UTC time zone, local time zone, let's say that. I think there should be more data. What I can do is I can hmm, I can make I can make 1,000 requests to this one. Uh, as you can see in this setup, only one of them is almost took this one. No, sorry for that. Only one of them took this one, and the remainings are very low compared to that one. But let's see these stats again. Oh, hits, misses, and TTL. Yeah. So that's it. This is how Elasticache works. In short, we created a bulky cache instance and we deployed it into the default VPC, but the Redis port is not accessible from the outside because Elasticache endpoints are private, not public. And then we deployed a Go application to same VPC, but inside EC2. And EC2 can connect to the Volky cache instance because we granted that access by using security groups. That's it. And I am the only one that can access to EC2 instance application, which is running on port 8080. And that is our design. So your front-facing application should live inside public VPC, or you should arrange its port. But the Elasticache instance, it is inside private area, so you cannot reach it publicly. That is the limitation. If you have any kind of question, I can happily answer that. Other than that, that was it. Thanks for watching this session. There will be more AWS videos coming. Most probably the next one will be AWS Lambda. I will try to explain how it works and how to deploy our applications there, how to scale them, how to make a request by using API gateway. It will be our second one in this series. Yeah, if you like the video, please like and subscribe to my channel, so it will trigger my main motivation to continue to do AWS related sessions. Of course, there will be more coming, not only related to AWS, but yeah, that's the summary. Have a nice day and night for all of you, and see you in next video. Bye bye.